So in this video, we want to look at a pretty popular effect, and that is turning something into dust. Now, this is a pretty simple version of this effect using the techniques we've already learned so far. So you will find much more advanced versions of this technique online, but this is something, we can deal with the techniques we learned so far. So what we want to do is we take this Mars statue and turn it into dust. And before we bring in anything, or after we brought it in, we use Atomy to double check if the size is correct. And there you have it. Of course, it's wrong. So let's scale that guy down with a transform node to something more reasonable, maybe something like this. All right, thanks, Tommy. And now let's start how to do this. Now, the idea here is that we combine different techniques and bring them back to make them look like one effect. And this is something you will see quite often. It's often not just one thing that you see, but actually multiple things that feel like one thing in combination. So what we want to do is we want to make this statue disappear and turn into dust. That's two things actually. First, we make him disappear. And what we can use for that is a Boolean node actually. So in its simplest form, we can just take a box or something and just animate it from top to bottom to make our guy here disappear. Of course, you can do much more complex things with spheres and all that, but this is a pretty simple way of doing this as a first test. And with Alt, we can set a keyframe on the position, and then we change the time. Maybe 80 frames are fine, and then we move the whole thing down, set another keyframe, and that didn't work. Why not? Oh, it did work. Okay, strange. So now it works, and all we have to do really is to put this into a Boolean node. So we want to subtract this probably, which is the default anyway. So let's see what happens. And it seems to work, but it has one problem, and that is we can see inside of our Mars here. And the reason is when you have something like that, then there's something wrong, because you could have get the same result with a clip node, which would be much faster. But the reason we use Boolean here is so that we have actually faces that are visible. So what went wrong here? It's simple. Our Mars is not properly watertight. There is no way, to my knowledge, to figure out where the hole in it is. There must be somewhere some face that is open or not completely closed or something. But there are multiple ways that we learned already to make something watertight. The first thing that I usually try is the simple polyfill. So a polyfill will simply find any kind of hole, and with a with some quads, I'm not able to usually close them. So I switch this to triangles, and then usually this should work. Let's have a look if this actually solved our problem. And no, it didn't. So we need something stronger here. So if a polyfill is not enough, then something that usually works is turning our geometry first into a volume, an SDF, and then convert it back. There's already a node doing this for us called remesh to grid. So this is a fast way of doing it. And then we just lower the division size. But just to repeat how this usually works and how it works internally is we use a VDB from polygons to turn this into an SDF. There it is. And yeah, there we go. Let's lower the voxel size to get more detail out of this. And then we convert this VDB back to a polygon with convert VDB. There you go. And then we have our Mars as one closed geometry. And this is exactly what the remesh is doing, just handy in one node. I take the old school route as usual, and let's see if that actually fixed our problem. And it did. Brilliant. Moving on. So what we have now is this version, and let's actually create a null node so that we see the end result. And it's a bit slow because, of course, it's a lot of calculation time needed. So you could even cache this because this is now something like, let's actually check how fast it is. Of course, that depends on the resolution of your SDF and all that. So how much calculation is needed. But if I visualize the speed, there it is under guides, then I end up with about 1.3 frames per second. So this is relatively slow. So I could quickly cache this, but instead I would just increase the resolution for now so that we have a quicker feedback. Well, maybe something like this. Yeah, and that's much faster. But of course, this would not be the resolution I would take for the final production. Now, before I move on, of course, this is a bit boring because it's a hard cut here, and this will actually make it much harder to hide this effect. So instead, what you should try is to take the box and maybe add a couple more divisions to it so that we have a lot of detail here, and then maybe use something like a mountain node to break this whole thing up a little bit. I would make sure to only move outwards to be positive, because sometimes when points are, inside of each other in the in one of the two objects, which can happen when you don't set it to positive, then the Boolean will not work properly. So this is usually something I would do. And then, I don't know, let's try something like this. And the idea here is that now the break area is not flat anymore, but actually broken up, which will make the whole thing look much more interesting. Lovely. So great, we have now our Mars disappear, but where is he going? He should turn into something, right? Well, this is a part where we create the dust emitter. And you might already guess what we're gonna do. We just use a second version of this, a second Boolean, but this time what we want is not what's left, but we want the intersection between the two objects. So let's switch this to intersect, but that's not actually what we wanted, because now we just get the other part that is inside of the box. Now what we actually wanted is the area where the two intersect as a flat area where we can then emit points from. How do we do that? Well, the trick is, remember, to just tell the Boolean, the second Boolean, that it should perceive the box in the second input as a flat sheet, not a 3D object that is filled. So we switch this here, set B, from solid to surface, and what we get, and let's use a null again to only see the result, is just this intersection area, not the whole geometry. This is, by the way, a pretty cool effect by itself. So you can use this to, I don't know, do some kind of, scan effect or something of an object. But we will use this here as an emitter for a pop simulation. So this is great. And all we really have to do now is we put this into a PopNet. And this will actually already work. Let's have a look. And we get a lot of points. And let's turn off the template, by the way. We get a lot of points where the emission area was. But it has a couple of problems. First of all, of course, the points stay in space because there's no force moving them. We will fix that in a second. And the second one is you can already see the jitter problem, which we will have to deal with later on. But let's start by adding actually some kind of force. If you wanted, you could add some gravity to this to make it more believable, but I think I will just take a pop wind, I think this time, not a pop force, even though the pop force would be totally fine. The pop wind just has the advantage for me that the points will not go too fast later on. So let's add a velocity. You can't see it, but it's positive x, so maybe, I don't know, 5 in x. And let's add a little bit of amplitude to it and see how this goes. And that's too strong. So let's lower this to 1 and let's keep the noise but lower the swirl size. That's actually not too bad. Maybe a bit more of that noise and an even smaller swirl size, because I want really to have some chaos here. Yeah, the horrible tweaking. Yeah, that's not too bad actually. I think I like that. Yes. The only problem here is that the points, especially in the beginning, you can see where they are spawned. Well, the first thing I would change before I tackle this is I would increase the amount by a lot. So let's increase the amount in the source, in the pop source, of course, maybe to 7 times as much. And then to judge this better, because the points are usually a bit too big in the viewport, I will make them smaller in the viewport in the display options under geometry. Let's turn the point size to 2, and then it looks a bit more like it will probably look like later, and then we can judge it better. And less, oh yeah, and actually let's just add a bit more wind velocity. That's it. Okay, I'm just playing around a little bit until I find the numbers that I like. Yeah, I think that's not too bad. I think I want to keep it at that. Of course, you can play around with this until you have something that you like more. But what I can see, it's still not enough points, and we still have the stepping. So let's fix this first. So more points, easy to fix. Let's go a bit crazy here. And there are different ways of making sure that the points will not, emit in this kind of staggering fashion. One way could be to give them some start velocity. So maybe we try that. And what I want to have is something that is relatively strong upwards and not so strong to the sides. So maybe something like that. And that is too strong. So let's lower this, maybe to 0.3 in Y. Yeah, that's not too bad. And as you can see, that actually breaks up our lines quite a lot. What we could try on top is the trick I showed you before under birth, the jitter birth time. If I set this to negative and forward, this will often help to interpolate the start position of the points. And you can see now even the last jitter should be gone. And I think it looks pretty good. What you could add here is now a collision object of my statue here. But I will, I think, leave it out because I think the effect will still be good enough. And the points that will go inside will not be visible anyway. So if I combine the two results now, you can see the idea. Let's just make sure that the colors are a bit more similar. So maybe not a complete white for my particles. So something like that maybe. And maybe the same on the statue. And now when you look at the result, it feels like there's one object disappearing and turning into dust, but actually it's two different effects. One is the disappearing and the other is actually the dust emission. And this is something you can use quite often to create an effect. So with a bit more love, of course, you can make it look a bit nicer than what we have here. So for example, let's now increase the resolution again so that our mass doesn't look like a blob. Just for now, let me turn the background dark because then we can see the effect a bit better. Oh yeah, actually I forgot an important thing. Let's make sure that our points will not live forever. So we change the lifespan or the life expectancy maybe to something like 3 or something with a variance maybe of 1, and then the whole thing will look much nicer. What you can also think about is controlling the p-scale by the age. So all kinds of things you can do with this. But if you look at the version we have right now in a flipbook, it looks like this. So this is how my version looks like. Of course, you know, yours can look completely different, especially when you put a bit more love into this. And then if you render this with motion blur and all this, it will look even better. So this is how it could look like if it's properly rendered. And you can see it's a pretty nice effect. Now, what it's mainly about for me, though, is that you understand the concept behind it. The adjustments and the little tweaks, that is your part to do to make it really shine. The whole effect is basically built by two elements. The first one is to make the statue disappear, and for this we can use a simple boolean. And the second boolean allows us to get this intersection area of the first boolean and use it for a popnet as the source for my points. And then it looks like the whole geometry is turning into dust. A good trick here is to break up the second geometry. Make sure it's a positive noise that you add to it. Otherwise, you might have intersections inside of the geometry and then your boolean will create weird results. But the advantage of that is that you will have a cutting area that is not just straight, but has some complexity to it as well. So yeah, I hope this is helpful. Thanks very much and see you later. Cheers.